Hi, welcome back to Physics Teacher. This is a grade 12 math contest, the Euclid contest from Waterloo University, and it involves geometric sequences. Give it a try, and I'll be right back with the solution. So, a geometric sequence is one where each term is obtained by multiplying the previous term by some common ratio. For example, 3, -6, 12, -24. So in this case, in order to get -6, we would have had to multiply 3 by -2. And then if you continue along this pattern, -6 times -2 is 12, 12 times -2 is -24. There's a geometric sequence. Now this one says we have some geometric sequence where the first term is a and our common ratio is r. And this first sequence has 4 terms, and if we add all those terms, we get 6 plus 6 root 2. So what does that look like? Well, the first term is a. The second term, if we add it, would be a times that common ratio, and then add the third term, where we're going to multiply by that common ratio again, so we'll write it as r squared, because it's r times r, and then the fourth term, which would be ar cubed. And it says, adding all of these, you get 6 plus 6 root 2. Okay, and then it says we have a second geometric sequence, where again, the first term is a, and the common ratio is r, but this one has 8 terms, and its sum is 30 plus 30 root 2. So this one would be a plus ar plus ar squared plus ar cubed. I wrote a 4. Let me change that. Here we go. Plus ar to the 4. Plus ar to the 5. Almost there. Almost there. Plus ar to the 7. There's 8 terms. And that's all going to equal 30 plus 30 root 2. Okay, something to notice with these 8 terms is the first 4 terms, if I put brackets there, is our first sequence. So this is simply 6 plus 6 root 2. And these next 4 terms, if I pull out our greatest common factor, which is r to the 4, then we get a plus ar plus ar squared plus ar cubed. We get that first sequence again. So this would be plus r to the 4 times 6 plus 6 root 2. And that's all going to equal that 30 plus 30 root 2. Alright, so that's one equation there, and I can solve for r. Let's actually factor it out. I can take a 6 plus 6 root 2, and multiply that by 1 plus r to the 4, which equals 30 plus 30 root 2, and then divide by that factor, so we have 30 plus 30 root 2, all over 6 plus 6 root 2, and that's very nice because that just works out to be 5. And then r to the 4 is 4, which would mean r squared is 2, which means that r is either plus or minus the square root of 2. Now we didn't need to know r, we need to find all possible values for a. But of course, in order to do that, we need to know r, and there's 2 possible values for r. So let's go back and look at our first sequence. I'm just going to make some room here. Okay, so now that we have some room, there's our first sequence, well, series since I'm adding them all, and it equals 6 plus 6 root 2. Now, let's look at first when r equals positive root 2. Let's sub in r as positive root 2. So we'll get a plus root 2 times a plus, this would be root 2 squared, which is just 2, so 2a, plus, and root 2 cubed is 2 root 2, as it would be the square root of 8, which is 2 root 2 times a. And that all equals 6 plus 6 root 2. Okay, so if we factor out an a, we get 1a and 2a, so that's 3. And here we have root 2 and 2 root 2, so plus 3 root 2, which all equals 6 plus 6 root 2. So this works out quite nicely, because 6 plus 6 root 2 divided by 3 plus 3 root 2 just equals 2. So one possible value for a is 2, and that is when r is the square root of 2. All right, well, what about when r equals negative root 2? We're going to do the same thing. Let's sub in r's negative root 2 into our first sequence there. So we have a, then we're going to have minus root 2a, and then we're going to have plus 2a, because r squared is a double negative, so plus 2a, and then minus 2 root 2a. And that'll be 6 plus 6 root 2. So in this case, if we factor out an a, we get 3 minus 3 root 2, which equals 6 plus 6 root 2. This one isn't as nice to solve, but we can do it. So 6 plus 6 root 2 over 3 minus 3 root 2. So first, we can factor out a 3 on the top and the bottom, and they'll cancel, and that'll leave us with 2 plus 2 root 2, all divided by 1 minus root 2. All right, so now we're going to have to rationalize the denominator. So we're going to multiply that by the conjugate of the denominator, so 1 plus root 2, all divided by 1 plus root 2. And that's going to leave us with 2 plus 2 root 2 plus 2 root 2 plus 4, all divided by 1 minus 2. So 1 minus 2 is just negative 1. And here we have 6 plus 4 root 2. But when we consider that negative 1, we get negative 6 minus 4 root 2. So that is our other possibility for a. So a can be 2, or a can be negative 6 minus 4 root 2.